first problem I wanted to look at is the integral of sine cubed cosine to the sixth times dx. And we talked yesterday at the end and said basically there are two options that we would like to work here. One option is we could let u equal cosine, and another option is that we could let u equal sine. Regardless of which approach we take, du is basically the other trig function. So if u is cosine x, du is negative sine x dx. And if instead we decide to let u equal sine, du then is cosine x dx. And we can start working with both, but in this problem, only one of those is a really good approach. So if we start with this first one, we would separate out which one do we want to separate to get du at the end. So if we're doing sine cubed cosine to the sixth and we're trying to get du, what do we need to do for that?
Separate sine.
Yeah, so we're going to separate one factor of sine for the du, and that's going to leave two factors of sine. Because there were three to begin with. And then we make a quick multiplication, multiplied by -1 inside and -1 outside. And now this is du at the end of the problem. We could do the same thing here where we separate out a cosine for the du. And now we don't have to deal with the negative, but aside from the negative, that's the same thing. And now in both approaches, we need to rewrite everything except for the du. So we need to rewrite everything other than the du in terms of whatever u is. What that means is that that's easy when the other trig function has an even power at this stage. So since we're trying to rewrite in terms of cosine, it's easy to rewrite sine here because sine has an easy power. We can rewrite sine squared as 1 minus cosine squared. And then we get that times cosine to the sixth. And then we still have negative sine x dx at the end. And now that's easy to rewrite in terms of u because we've got, oops, let's make that negative. So equals negative 1 minus u squared times u to the sixth times du. Does everybody follow it to there? What's going on? Okay, now technically you can do the same basic thing on the second one. And what we kind of went through the algebra of yesterday is when you have this bigger power, cosine's the one that needs to be rewritten now because we need it in terms of sine. We can rewrite this as 1 minus sine squared to the 5/2 power. And so we've got sine cubed, well, we've got u cubed times 1 minus u squared to the 5/2 times du, and nothing is technically wrong. So the steps that I've done in blue are correct. The steps I've done in red are correct, but only one of those is very useful to do the problem. This 5/2 makes this very, very difficult or maybe impossible to deal with. So we don't want to use this approach. This is what's bad about the problem. Let's do it black. So this we don't want. The fact that this is technically a 1, that's good. Here, that doesn't need to be a 1, but as long as it's a positive integer, we can do it. So if this was 2 or 3 or 4, that'd be fine. And so what we kind of said at the very end yesterday is you can trace back where that comes from. So this 5/2 that was bad was 5/2 here. That was because this was 5. originally that was 6. And so the idea is the one that you rewrite, the one that you're going to need to rewrite, needs to start as an odd power. So the one you're rewriting is the one that is not u. That means the one that is not u needs to have an odd power in the beginning of the problem. Does that make sense to everybody to think of it that way? Okay, so if we're dealing with these where you have sine to a power, cosine to a power, the quick way to think of it is that if one of them has an odd power, you should let u equal the other one. So here, because sine had an odd power, u should be cosine. Because cosine had an even power, this approach down here is not a good approach for the problem. Does that make sense? Okay, so once we're to this point, let's finish the problem and then let's kind of summarize what we're talking about. But we don't want this red writing at all. We don't want to deal with that. And so we'll erase that. But we'll go ahead and finish out this problem. This one's a little bit quicker than yesterday because that's to the first power. That binomial is to the first power. So we distribute the u to the 6th. But if it weren't to the first power, if it was squared or cubed or something like that, you'd multiply it out first, which might be tedious, but is not real hard. And now you split up this integral, and the negative outside carries to both integrals. So we get negative integral u to the 6th du plus the integral of u to the 8th du. That's then negative 1/7 u to the 7th plus 1/9 u to the 9th plus c. And now we've got negative 1/7 cosine to the 7th x plus 1/9 cosine to the 9th plus c. And that's the answer on this problem. All right, any questions at all on that? So feel free to ask if you do have any. You can put it in the chat or unmute yourself, that's fine. Okay, so if one is odd, we should let u equal the other for sine and cosine. Secant and tangent and other trig functions, this rule does not work, but it does here. If one of them has a positive odd power, let u equal the other one. If they're both odd, then either approach, either one works. You can let u equal cosine, you can let u equal sine. It might be smart to pick it so that the power here is as small as possible, but you don't have to. You can do it either way. Your answer would look different, but because of trig identities, it would either be exactly the same, they'd be equivalent, or they'd be off by a constant. So like maybe it'd be one higher, and so the +1 would be factored into the plus c. So when we're doing powers of sine and cosine, we're kind of using these ideas. We're using the fact that the derivative of sine is cosine, which I think we all probably know. And the derivative of cosine is sine. And so the idea is if u is, I'm sorry, derivative of cosine is negative sine. But if u is sine x, du is cosine dx. And then if u is cosine x, du is negative sine x dx. We're also using the trig identity that sine squared plus cosine squared is 1. And so this identity always lets you rewrite sine in terms of cosine or cosine in terms of sine, but it's usually useful when you're rewriting even powers. You can do it for any power, but it's usually only useful in integrals if it's an even power that you're rewriting. Does that make sense? Okay, so if one of them's odd, let u equal the other one. If they're both odd, you can pick your favorite. So then what case are we not covering? So if one of them is odd, let u equal the other one. If they're both odd, you can pick. So then what else could happen?
If they're both even.
Yeah, so if they're both even, this approach does not work well. Does that make sense? And by not work well, I mean does not work. And so when they're both even, or if there's only one of them, if it's just sine and it has an even power, if it's just cosine and it has an even power, you should use what's called half angle formulas. And just kind of as a heads up, when you're looking at the homework, some of the homework problems are pulled from different textbooks. For some reason, some textbooks are calling them double angle formulas. These are typically called half angle formulas, but either way, you have two of those. You have sine squared x equals 1/2 times 1 minus cosine of 2x. And you have cosine squared x is equal to 1/2 times 1 plus cosine of 2x. And then just kind of as a heads up, it is not a mistake that this is both cosine. These are both cosine. These are both 1/2. The only difference in the identity is that the sine one has a minus here. The cosine one has a plus here. And then this is sine squared and this is cosine squared. This is just cosine, but it's cosine of 2x. So that's not cosine squared. It's like 2x is inside of cosine. Does that make sense to everybody? This is a variation on the half angle identity that is typically covered in pre-calculus or trig. So if you took a class like that, you probably went over one, and it probably was like sine x equals plus or minus the square root of something. And this is a manipulation on that identity. If you don't remember that, okay, fair enough, but we need to be able to use these two identities. One other thing I want to say about the identity. So if you're not already, look at the screen for just a minute. So the identity is relatively easy to use, but you got to think for a second about, like, if this is sine squared of, say, 3x. So if I have sine squared of 3x, then what the identity is saying that is, if this is 3x, then this would be 2 times 3x. So this would be 6x. Does that make sense to everybody? So that would become 1/2 times 1 minus cosine of 6x, based on what this is already saying. It's just sometimes in the middle of a big problem, it's easy to mess this up. So does everybody see why it's that? That makes sense? Okay, any questions so far? All right. So when both powers are even, then you use these identities in order to do the integral. And so I want to look at a problem where we do that. So the next problem I want to do is the integral of cosine squared x dx. And then I'm going to write this half angle formula over here on the right, assuming that we don't have it memorized yet. And I guess with open book, you can write it down and just have this. So that's completely fine. So 1 minus cosine, or 1 plus cosine of 2x is the identity. And man, my fault. No integral sign on that. And that was actually going to be the next question, even though I kind of messed it up. So look closely at this identity for a second. And I want you to count how many integral signs are in that identity. How many integral signs are in that identity? You can unmute yourself and answer, or put it in the chat. How many integral signs are in here?
None.
None. So there are no integral signs in here. So when you use this identity, and man, there is a dx, but that's because I'm losing my mind a little bit. It should say this: there's no dx, there's no integral sign. Cosine squared is equal to that. The point is that when you do the identity, you have not done the integral in any way. You are rewriting it in a way that's easier to do the integral. Does that make sense? Okay, and me putting a dx in at first and an integral sign, I understand makes that more confusing, so sorry about that. But the identity says this, and there is no integral sign, there is no dx. So what you do is you rewrite this way. And now the problem we have does have an integral sign. But because of that trig identity, we can rewrite the problem that way, and we can factor the 1/2 out. Does that make sense? And now this is actually right. It's not me losing my mind and putting in an integral sign when I'm not supposed to. This is what's supposed to be there. You guys good? Okay, why is that helpful? What can we now do with this problem that in order to get the problem to work?
You can just do U sub.
Yeah, you can do U sub. I'd probably split it first, but you can split it up and then do U sub on the second one. Does that make sense? So let's split it up and make it 1/2 integral 1 dx plus 1/2 integral cosine of 2x dx. Does everybody follow that? Okay, now I want you to write the answer. If you want to show the U sub, you can. Or this is one where probably it's quick enough where you don't need to show the U sub and you can do it in your head. But let me give you a second to write an answer and then check it with me in just a minute. And so we should get it to there. Is that what we're getting? Yeah, it's good. Any questions on how to get that? I think it's pretty straightforward. Is that right? Okay. Now, I want to do another one like that, but it's real important that when you're talking about these standard problems, and by standard problems, I mean ones that are in the form cosine to the m sine to the n dx, where you have these nice powers of sine and cosine. The half angle identities work well on those only when all of the powers are even. Does that make sense? So now there may be some weird ones where you have fractional powers or negative powers, and those don't fit the mold of what I'm talking about. But when I'm talking about like nice positive integer powers of sine and cosine, where these are like 1, 2, 3, 4, 5, 6, 7, and so on, then the only time you would apply this identity is if they're both even. If you apply them to ones where you did not start with both even powers, you're going to make a mess of the problem. It's not going to work out, or very rarely would it work out. Does that make sense? Everybody clear? Okay, so the only time you should be using the half angle formulas are the two instances. One is if it starts as all even, not once you get it to here where now it's all even. Don't start applying them there because you're going to make it not work out. Only if it starts as all even. If one of them starts as odd, you should be using this method. Does that make sense to everybody? Everybody clear? And again, that's easy to kind of know now, but in the middle of an exam or when you're doing a bunch of problems and you're kind of losing your mind, then you have to be real careful. So you should only be applying these when they start as both even powers. All right. So I want to look at one. Second situation would be if it's a really weird problem that doesn't really fit this, then okay, maybe there would be a way to apply this, but that would be very rare. All right, so the next one I want to look at is actually cosine to the fourth. And this is on the PDF for powers of sine and cosine, and it is number 8. So if you go into the trig integrals folder in the techniques of integration, unit 2, so it's unit 2 folder 4, I think, might be folder 5. Let me double check. Unit 2 folder. I'm sorry, unit 1, techniques of integration. Unit 1, folder 5. Although there is no folder 3, so that's whatever. But it's unit 1, folder 5. And if you go into unit 1, folder 5, there's the first handout is powers of sine and cosine, and you have solutions to it. And my solution to this, I made like a mistake early, and it's all wrong. So use the solution I'm about to give you for this problem. Does that make sense? I made like a little mistake, but it screwed everything up. So all right, so this problem though is one where you have all even powers of sine and cosine. And so then what we want to think is, okay, this is cosine squared. And so what's going to happen is then we get that entire identity squared. And then that gets us 1/4 integral 1 plus cosine 2x squared. And I might not write all of those steps out every time, but I wanted to show you that so we can kind of see what's going on. Questions on how that's working? Okay, and before we go on, if this had been 6, what would change? So would this still be a 2, and would this still be a 2? Would they be like 2 and 4, or 3 and 3, or 2 and 3, or what?
2 and 3.
So, yeah, 2 and 3. And you'd want this one to be the 3, because the idea is to get cosine squared, because that's the one we can rewrite. Does everybody see that? Okay, so if you get to this step and it was to the 6th, this would be 1/8, and this would be 3. This would be 1/8, and this would be 3. Does that make sense to everybody? Okay. All right, so then with the one we actually have, we're going to expand that, and we get 1/4 integral 1 plus 2 cosine of 2x plus cosine squared of 2x dx. Everybody follow? Now we're going to split that into 3 integrals. So we're going to keep the 1/4 on all of them. And on the middle, I'm going to pull the 2 out. And that makes it 2/4, which is, of course, 1/2. So if you want to make that 1/2, you can. I'm just trying to make it clear what happened. So I kept the 1/4 and I pulled the 2 out. And then that obviously reduces to 1/2. Okay, questions to there? Yes, good. All right, and then the first integral is very easy. The second integral is a quick u substitution. What about the third integral? So what do we do with this?
You have to use half angle again.
Yeah, you use half angle again. Its powers of sine and cosine, and they're both even. So I'm going to do the first 2 parts, but as a heads up, it's 1/2 times the integral 1 plus cosine of 4x, because that identity said that cosine squared is 1/2 times 1 plus cosine of 2x. So it's like when x is on the left, it's 2x on the right. If 2x is on the left, it's 4x on the right, because you double whatever's there. Does that make sense? All right. And now I'm going to carry the other ones down. The integral of 1 dx is 1x. So we get 1/4 x plus 2/4. I'm going to leave that just so it's clear if you're looking later what's going on. But it's 2/4 times 1/2 sine of 2x, and then plus this last part. Now that's 1/4 x plus 1/4 sine of 2x, because we get 2/8. And now that's 1/8, but we're going to split that integral into 2 integrals. The 1/8 goes on both of them. Questions on that? That's good. Okay. And now we carry everything down. So we get 1/4 x plus 1/4 sine 2x. And now the integral of that third one is x, so we get 1/8 x. And then the last one is going to be 1 over 32 sine of 4x, because that's one of the quick u substitutions where u is 4x, du is 4 dx. So you put a 4 inside and a 1 over 4 outside. There's one more thing we can do, but does everybody follow it to here? Okay. And now the only other thing we really should do is combine 1/4 x plus 1/8 x. That's 3x over 8 or 3/8 x. Just by getting a common denominator, but that is then the answer to this. Okay. Questions? All right, so it's kind of a lot of tedious algebra. If this was to the 6th, it would be more tedious algebra. You'd have this to the 3rd power. You'll see on the homework, like if it's sine squared times cosine squared, then you get like this times the other one. And that's actually not as bad, but you work out the algebra, it's the same basic thing. So if all the powers are even, that's when you use half angle. Also, if you go into that worksheet I was talking about, so this PDF that's in the Unit 1 folder, there are worked out solutions to these. And like I said, this one was wrong, but the rest of them should be good. So you can see me working out more problems like this, but they're basically all like this. And so if we go back up here, these, so the idea is if 1 power is odd, let u equal the other one. And otherwise, if all powers are even, then use half angle Hordos. Now that's if they're all positive integers. When you start dealing with fractions and square roots and things like that, you try to make one of these approaches work. You try to make this first approach work. But if it doesn't, you may have to be creative, and this general approach may not always work. But this will always work when they're positive integers. I want to look at another one, but any questions on this idea? Okay. All right. And so then let's look at the integral of sine to the 5th x dx and see if we can think about what to do. So we've done cosine squared, cosine to the 4th. Now we're going to do sine to the 5th. Any ideas on what we should do? I'll let you guys tell me. You can type it in chat if you don't want to unmute yourself. But I want to know what you think. Go ahead.
Would you split it apart into like sine 3x and sine 2x?
You do something like that. But what u sub should we use? I think what you're saying, Abigail, is not wrong. Like it's close. I don't think that's the way you end up splitting it, but close to that. You do split it up. Okay, what's the rule we just wrote on that, like way up at the top of the screen? If you have powers of sine and cosine, if one of them is not quite, Jordan in chat. So if one of them is odd, what are we supposed to do? If one of them has an odd power, then you let u equal what?
Sine.
The other one. So does one of them have an odd power? Yeah, sine has an odd power. So let's let u equal cosine. And I understand that's weird because cosine's not in the problem, but it works. So The reason it works is because of what Abigail's saying. Now, what you're saying is you could split them up. You don't want to split them up the way you said, but how do we want to split them up now? What do you guys think?
Sine and sine to the fourth.
Yeah, so we're going to split it into sine to the fourth times sine. And now, okay, I need a negative there, so a negative here. And that's the du. But now I can rewrite that in terms of cosine. And now we have more work to do, but is everybody clear how to get it to there? And that's real weird because you're letting u equal something that's not even in the problem. But after you rewrite it, it is in the problem. Does that make sense to everybody? All right, so then this is negative integral 1 minus 2u squared plus u to the fourth du. And now you can split it and the negative carries. And that's it so far. Does that make sense? Questions? Okay.
Why is it u to the fifth and not u to the fourth there?
No idea. Don't randomly change things from 4 to 5, probably.
Okay,
Thank
sorry,
you.
I was just confused.
No, you're fine. That's the stuff I like to do sometimes. I'm sure you guys do every now and then on a test or something. So yeah, I do that too. Sorry, that's for sure 4. Does that make sense, everybody? Now it'll become 5, right? But yeah, my fault. Sorry, guys. And now that's minus 1/5 u to the fifth at this stage. Thank you for telling me that. Other questions? I think I'm good now. Is that right? All right. And now u was cosine. So we get negative cosine x plus 2/3 cosine to the third x minus 1/5 cosine to the fifth x plus c, and that's the answer. Is that good? Any questions so far? All right. Okay, so that is powers of sine and cosine. I want to talk about what happens in this case. All right, so for these techniques to work, the thing inside of the trig function does not have to be x, but it does have to be the same. Does that make sense? So like they're both 6x here. You can apply what we're doing from the beginning here. So like if you wanted to let u equal sine of 6x, you can do that. It's a little easier to mess up because you're going to have to apply the chain rule every time you're dealing with stuff. So what I would recommend that you do on a problem like this is first kind of u sub out the 6x. So like before we do anything for real with the problem, if you let u equal 6x, du is 6 dx. And so you can very quickly get it. And you might even be able to skip this step. In fact, I probably would skip this step. But you multiply inside by 6 and outside by 1/6. And so now you've got 1/6 integral cosine to the fifth u sine to the fourth u du. And now it's like the ones we've been doing, except 1/6 just sits there the whole time. Does that make sense? I think it's easier to deal with it that way than to have to deal with u equals sine of 6x. Although you could let u equal sine of 6x. But if you u sub this out, now, okay, you're going to let v, one of them is odd, so you let u equal the other. So we're going to say v is sine of u, dv is cosine of u du. And now you're going to do this exactly the same way. And we're just using v. It's not integration by parts. It's not because of that. It's just we're using a different letter. And so you continue it just like what we were doing before. And then at the very end, you'll get an answer in terms of u, and then you got to go back to 6x. It's a little more work, but not like a ton. Does that make sense to everybody, what I'm talking about? So you'll see that on the homework sum. What if this was like 6x squared? They'd have to like put an x here, but if you have x and then 6x squared, you do the same thing pretty much. You'd end up with 1/12 out here. But you can u sub that out to make it kind of match, not a basic form, but a form that we know how to handle. That make sense? Questions at all so far? Okay, so the plan was to go ahead into powers of secant and tangent. But I think a better plan is to not do that. And I think what would be a better plan is for you guys to get, and it's not because we don't have time, we have time, but I think it'd be better for you guys to get good at this and cut one of the homeworks. So there were going to be 5 homeworks due Monday. We're going to make it so there's only 4. So if you log into WebAssign, you'll see powers of secant and tangent. I'm going to push that to the next week. So you've got 4 assignments, which is quite a bit anyway. So integration by parts 1, integration by parts 2, and 3. Hopefully we're done with those for the most part already. And then you have the powers of sine and cosine. Those we'll say are due Monday at midnight. But like the idea is not for you to have a bunch of weekend homework. Like I'm hoping you're done with most of it already and you have a few questions, and like try to get this done before tomorrow and or on Monday. Like, you know, if you have to do some over the weekend, okay, but like please don't do 4 assignments this weekend. That's definitely not the idea. The idea is for you guys to be able to pace yourself how you want. But those 4 assignments we're gonna make due. I'll push the powers of secant and tangent until the next Monday. We should have plenty of time to cover everything next week still. But powers of secant and tangent makes a lot more sense if we're really good at what's going on here. So we'll cover that on Monday, and then we'll move into trig sub on Tuesday. And we should be good to go. I think that's it for today. If you do have homework questions or whatever, feel free to stick around. If not, have a great weekend. I will see you guys Monday. If you want to meet up tomorrow, stick around and let me know that so we can figure that out. But otherwise, I'll see you guys Monday. Have a good weekend. Thanks for coming.